Stop guessing. Here's when to use Microstrip versus Stripline. Your impedance calculator has both, but the real question is which fits your design. Microstrip is a trace on the outer layer over a ground plane. Stripline is a trace buried between two reference planes. The choice changes impedance control, shielding, loss, and routing, and most designers pick one by default or on wrong assumptions instead of by requirement. Today, I'm showing you the pros, cons, and when to choose each so you can design with intent. Microstrip sits on the outer layer with dielectric below and air above. Pros: easy access for probing and tuning, wider traces for the same impedance, can have lower conductor loss in many cases, geometry and frequency matter. Simpler stockup, you only need one reference plane, and better thermal dissipation. Surface traces radiate heat to air. Stripline is trapped in the dielectric thermal blanket. Cons: it's exposed. No shielding from the top, so you get radiation, crosstalk from nearby traces, and sensitivity to solder mask and nearby components. Impedance is frequency dependent from two effects: the field partly in air, effective dielectric constant changes with frequency, and substrate material dispersion. The tool's microstrip model accounts for both. Stripline sits between two reference planes. Pros: excellent EMI shielding, no radiation to the outside, lower crosstalk because the field is confined, and impedance is much more stable with frequency since the field is entirely in dielectric. Cons: narrower traces for the same impedance. Stripline eliminates radiation loss but adds dielectric loss. Whether total loss is higher or lower than microstrip depends on frequency and material. Slower propagation: the field is entirely in dielectric, so signals travel slower than in a microstrip, which matters for time-of-flight sensitive digital lines. And you need two reference plans, so your stockup has to support it. The impedance calculator in the tool lets you pick your signal and reference layers from the stockup. Select outer plus ground for microstrip or inner plus two planes for stripline, and it computes trace width for 50, 75, or 100 ohms at your operating frequency. Routing: microstrip is ideal for outer layers, antenna feeds, test points, or anything you need to probe or tune. Stripline is ideal for inner layers, dense multi-layer boards, sensitive analog, or high-speed digital where you don't want noise coupling in or out. On a four-layer board, outer microstrip is simple. If you want inner stripline, you need a signal, ground, signal, power pattern, or similar. The PCB stockup generator has a stripline inner primary goal that builds exactly that. When to choose: use microstrip when you need easy access, can have lower conductor loss in many cases, geometry and frequency matter, or your board is mostly 2 to 4 layers. Use stripline when you need EMI control, you're mixing RF with sensitive analog or digital, or you're routing on inner layers by design. In real boards, vias and layer transitions matter just as much as the line type, and microstrip to stripline transitions need proper vias design. The impedance calculator in the tool lets you pick your signal and reference layers from the stockup. Select outer plus ground for microstrip or inner plus two planes for stripline, and it computes trace width for 50, 75, or 100 ohms at your operating frequency. The takeaway: microstrip for outer layers, probing, and simpler stacks. Stripline for inner layers, shielding, and EMI control. Don't guess, match the structure to your requirements. Check the show notes for the PCB stockup generator. Use the impedance calculator's microstrip and stripline tabs to get trace widths for your stockup before you fab. Now go build something with the right transmission line.